Profound. Now we're going to move to the the first session of the symposium. In this session, we're going to be hearing from a very diverse set of speakers. We have Dr. Ghosh. He's going to be talking about land restoration for greater ecological resilience in semi-arid ecosystems. The moderator of the session is Dr. Rafael de Silveira Bueno. Dr. Rafael, are you online?
Yes, I'm here. So Avijit Ghosh is currently working as a scientist at the ICAR Indian Grassland and Fodder Research Institute. He has a PhD in soil science and agricultural chemistry, published more than 70 international research papers, developed the concept of soil functionality in eco-restored lands, and significantly contributed to the restoration of pasture lands in India. He has also been awarded as Youngest Scientist Award by the Indian Science Congress and the Japan International Award for Young Agricultural Researchers from the Japan government. So congratulations, Avijit, and the floor is yours.
Restricted to the land restoration part for greater ecological resilience in semi-arid ecosystems. In semi-arid, in India and as well as in the world, we are considering soil as a service provider now. So soil is having very economic importance as well as a very high pressure to provide its services like provisioning services, regulating services, supporting services, and cultural services. And these are all the interaction that is taking place in the soil in presence of land system like biodiversity maintenance, industrial production, economic resources, and human habitation. And they are also, the soil is also responsible for cleaning of pollutants and running the biogeochemical cycles. So our target is to achieve greater ecological resilience in the soil system by applying proper ecological designing and with behavioral changes, while our aim is to protect the cultural heritage as well as the natural biodiversity. And we also care for the soil erosion and land degradation. So the present, our concern is to have effective soil conservation strategies that aids in achieving this achieving greater resilience in soil. This is the present status of the soil erosion or soil degradation. You can say approximately 52% of agricultural land is degraded in one and other form. And the semi-arid region also faces the problem like low crop response to fertilizer, progressive growth, progressive nutrient deficiency, and nutrient imbalances, as well as declining soil organic carbon. So what alternative use we can do for degraded land? Because degraded land cannot support the commercial crop cultivation, but they can support the alternate land use like silvopastoral system, hortipastoral system, and pasture land restoration and rejuvenation are the major options that we have to restore the degraded land. We are effectively working on restoration aspect of degraded land in semi-arid India, where we have developed some silvopastoral system. These are the trees and grasses component of the silvopastoral system, and they are spread in an area of approximately 10 hectares of lands, and they are when we analyze them, the silvopastoral system, the carbon sequestration and biodiversity is improved after 10 years of restoration activity. We have seen it. And also the restoration efficiency, when we consider many systems, we found that the ERE, that is eco-restoration, ecological restoration efficiency, was the highest for Moras alba-based silvopastoral system when we integrated it with panicum as well as Sencras-based grass. And the carbon management index was also higher for these systems. As we calculate the economics and integrate with the sustainable developmental goal, we find that these systems can effectively contribute to the achieving 5 sustainable development goal, that is SDG 1, SDG 2, SDG 8, SDG 12, and SDG 13, that are related to reducing poverty, reducing hunger, and improving carbon sequestration, and also increasing the economic benefits of and we have found that this silvopastoral system had a benefit cost ratio of more than 2.17. These are some of the systems that we have established in, and some hortipastoral system we have also developed here for land restoration aspect, where we have used Psidium guajava and Emblica officinalis as fruit tree, and we have used Sencras ciliaris and Stylocenthus siaprana as pasture to utilize the interspaces of the between the trees for maximum land utilization. And we have also integrated it with the moisture conservation technique, that is staggered contour trench, and we have found that the tree plus pasture system with moisture conservation can effectively improve the crop yield as well as soil functional diversity and microbial biodiversity and other soil properties like organic carbon and nutrient availability. And when we build the equation with time and restoration time and the ecosystem service, we find that as the time progresses, the degree of return from the ecosystem is improving gradually with restoration time. These are some of the pictures that we have restored in our area. We have also grazing is a major problem in semi-arid India. So we have designed a grazing strategy, that is low intensity rotational grazing in our semi-arid region, where we allow the small ruminants to graze the natural pasture up to 7 months, and that is indicated by the brown area, and green area we go for we do not allow grazing. So the as the grazing is removed, the pasture land, the biomass regrowth take place, and modification in plant diversity as well as adaptation of soil microbial community take place, and soil functional diversity also is improved, and microbial and as well as soil nutrient stoichiometry is also altered to support the vegetation growth and regrowth of the vegetation that allows the animal to graze in the next year again. Also, we have restored some pasture land by using the native grass species, and the restored land has improved the dry matter yield or pasture yield of the area, that is by 3 to 4 megagram per hectare, and soil organic carbon has improved marginally by 8 to 7%, and soil functionality has improved by 4.2 to 6.5 folds after restoration of 5 years. And carbon accumulation proficiency as well as nutrient cycling capacity has also improved significantly. And the carbon sequestered in the community pasture land, we have also converted to the payment carbon credit, and we have also paid to the local villagers or local community to encourage them in the restoration activity and their active involvement in the restoration process. We have also developed some silviculture system for land restoration purpose. And these are the trees where we have used in the silviculture system, and we have found that the soil functionality is significantly improved after restoration by restoration process. After the restoration of up to 7 to 8 years. These are the system that we have established, and also we have calculated the range grasses, how the range grasses like Cenchrus ciliaris, Megatherius maximum, Chrysopogon fulvus, Heteropogon contortus, Sehima nervosum, and Vetiveria zygenoides can effectively improve the soil functionality after restoration for 6 to 7 years when they are incorporated in the active restoration process of land. And we have found that they can effectively improve the carbon accumulation proficiency by 2.2 times, and ecosystem services can be improved by 25 to 37% after land restoration for 5 to 7 years involving these grasses. These are the some pasture land which we have restored effectively. And also we have developed a smart fertilizer for the supply of nitrogen and phosphorus to the range grasses using the that is called Nutrigel, that is developed from rice straw, and it can effectively save 25% of the nitrogen and phosphorus fertilizer to reduce the cost of cultivation and boost the economic profit of the farmers. But what is needed? Basically, UNO has provided guidelines regarding this that I am depicting here. They have given 10-point guideline to improve the restoration activity, as well as the engage more people in the restoration process. They are empowering a global movement like Save Soil movement in India. It has run. Financing the restoration process on the ground, like for payment for ecosystem services, we can consider. And we have to set right incentives to the farmers or the local people or community who are actively involving and investing their time and efforts in the restoration process. We have to also celebrate our leadership, and others are the investment in research, building capacity, celebrating culture of restoration. And we have to also must listen and learn from the local community. They are the master of restoration process because they are living in that ecosystem, and they are culturing the restoration process. So our broader aim is to achieve land degradation neutrality, sustainable developmental goal, and carbon neutrality. I sincerely acknowledge our DG, our Ministry of Agriculture, Farmers Welfare, Director, our institute, and I also sincerely thank the Director of the Green Institute for inviting me on such prestigious platform. Thank you.
Okay, thank you so much, Avijit, with a very interesting example showing us all of the, yes, I was asking you to adjust your camera, and also with practical examples and pictures and data about also the impressive speed of restoration, no? Using these different management in pasture lands. I have one question. What about the engagement of the shepherds, you know, the people who owns the animals? Do you think that how they see this at the beginning when the pasture is dry, and then after with the results, how do you follow this social aspect of your projects?
Actually, we have involved the farmers. We have allowed the farmers to sell the product that is growing in the pasture land. So they are actually interested in managing the pasture lands, because in the next year what will come as a produce, they will be able to sell, and they will be able to use for their own animal also. So they are interested in saving in the restoration activity also, and the protecting also they are interested in protecting the restored pasture land, as we have given them the right to sell that. And also we have formed a protection committee, so that there is no there is a proper rule there. The rule is decided by that protection committee of the village, and they follow the local farmers and villagers follow that rule.
Okay, thank you. We have a question from the audience. Kaula El Khatib. Thank you so much for the presentation. He wants to know more deeply the difference between silvopastoral systems and hortipastoral systems, and which of them is more efficient for tackle climate change and land degradation.
Actually, the system, the difference is not much. Only the difference is that in silvopasture system we have the trees, and in fruit, and in horticulture system we have also trees, but these are fruit trees that produces fruits like like Psidium guajava and Emblica officinalis that are suitable to the fruit consumption for human consumption also. And as per the climate aspect, we have seen that they both are efficient in our condition for carbon sequestration. So they are effective in mitigating the climate change also.
Okay. There is another question from Wesley Pereira. Are your projects covered under the ecosystem accounting framework to quantify the economic benefits?
No, we have not. Our project is not still in the ecosystem accounting framework, but on our own basis, we have calculated the economic benefits of the program based on our imports required and output we have gained from that project.
Well, I have one last question. How do you protect the plants, the trees, or the other plant species also in the horticultural system from the animals? Because usually, especially when the vegetation is dry,
we have to initially there is the more damage done by the animals. So initially we involve the people, and then we protect them using tree guard. That is aluminum based or iron cast based tree guard is available in our country. Or you can use for natural purpose you can use bamboo based tree guard, and that we use to protect the trees at the initial age.
Okay, and the animals are sheep, goats, cows?
No, we have in case our animal is on sheep and goats, small ruminants.
Okay. Perhaps if we have time, there is a last question. Thank you for the presentation. Looking at the addition of fertilizer you mentioned, in drylands where the land is brittle, are there any disadvantages of the application of fertilizers?
Yeah, there are disadvantages. Like in dry land, when we apply fertilizer, if moisture is not there, the nutrient is not solubilized. So it is not available to the plant. So we have to plan we actually use UAV, that is unmanned aerial vehicle or drone for fertilizer application in those pasture land. And using that drone, we with liquid fertilizer we spray after, and we also do not spray randomly. We spray 2 to 3 days after when the rain after precipitation or rainfall, so that the moisture is proper for solubilization of the nutrient also.
Okay, yeah, it's a problem in these dryland areas. Okay, thank you so much for your presentation. Congratulations for the work.
Thank you very much.